So for question 5 then, we have a mass of 6 kilograms, so a weight of 6 newtons, resting on a rough plane. Mu is 0.4, so I've put in my normal contact force, and then there is a force acting in this direction, keeping the block on the plane. Now I like to draw my forces all coming out of the same point, so I would put my P force over here rather than coming into the block. I'm going to put it coming out of the block. It makes no difference. And then we're told that the block is on the point of moving up the plane, which means friction must be acting down the plane. So my frictional force I'm going to call Fr, and that's coming down the plane. So what I need to do is resolve my forces that are not parallel and perpendicular to the plane. So the first one I'm going to do is this 6 Newton force here. So I'm going to have a component that's perpendicular to the plane and another component that is parallel to the plane. I'll write it just underneath there. Now if this angle is 30, this angle here is also 30. So this component is adjacent to the 30, so this is going to be 6g cos 30, and this force here then is going to be 6g sine 30, and then I'm going to get rid of my 6g force because I don't need it any longer. I need to do the same thing then to the P force. So again I'm going to get two components, one going up here parallel to the plane, and another one coming down here perpendicular to the plane. So let's just draw that off to the side a bit. Now again, this angle here is 30 degrees. So this component is going to be P cos 30, and this component coming down here then would be P sine 30, and I'm going to get rid of this P force because I've replaced it with two components, and then I'm ready to do my questions. So the first one says to find the normal reaction exerted on the box by the plane. So in order to do this, what I need to do is resolve my forces perpendicular to the plane. So if I resolve my forces perpendicular to the plane, N going up is P sine 30 plus 6g cos 30. So I can't find N yet because I don't know what P is. So if I resolve my forces parallel to the plane, then I've got friction plus 6g sine 30 going down, and I've got P cos 30 going up. Again, I've got two unknowns in there, so that's not a lot of use. But the third thing I can do is I can use friction equals mu times R. So my maximum friction is equal to mu times R. So my frictional force is equal to mu, which is 0.4, multiplied by N. And this is my starting point really. So what I'm now going to do is I'm going to use my first two equations here, and I'm going to substitute them into the third one. So I can rearrange this second equation to say friction is equal to friction is equal to P cos 30 minus 6g sine 30. So my friction, from here, P cos 30 minus 6g sine 30, and this is equal to 0.4 multiplied by N. Now N is P sine 30 plus 6g cos 30. So I've now got an equation that's only got P's in it. Now if you look back at the question says part A, find the normal reaction, and part B, find the value of P. Now it doesn't really matter which order you find those in as long as you label them properly. So I'm going to call this B because I'm going to find P first, and then I will find A later on. So what I need to do now is simplify this and collect all my P terms together. So P cos 30 minus 6g sine 30 is equal to 0.4 P sine 30, and then 0.4 times 6g cos 30. So I want my p's on one side, everything else on the other side. So p cos 30 minus 0.4 p sine 30 is going to be equal to 0.4 times 6g cos 30, and then if I take this over it becomes positive, so plus 6g sine 30. So cos 30 is a root 3 over 2, so root 3 over 2p. Sine 30 is a half, so a half of 0.4 is 0.2, so 0.2p. And over here I've got 6g times cos 30, which is root 3 over 2. So I've got 0.4 times 6g times root 3 over 2. And I've got 6g here multiplied by sine 30, which is a half. So root 3 over 2p minus 0.2p gives me 1.332p. Just put that in your calculator. And again on this side, put all this lot in your calculator, and what you end up with is 99.538. So divide both sides by 1.332, and P comes out to be 74.7 newtons, 74.725 to more places of accuracy. So that's your value of P. So that's part B. Having got P, what I'm then going to do is go back and do part A. Now part A asks me to find the normal contact force, so all I'm going to do is take my first equation up here, the one that was perpendicular, and say n is equal to 74.725 times the sine of 30 plus 6g times the cos of 30, and again that goes in my calculator and I get 88.285. so to three significant figures I'm looking at 88.3 newtons as my answer. Right, part C then removes the P force and asks and tells us to show that the box will now start moving down the plane. Now I would draw another diagram because I think it's going to get very messy here if you don't, because you've got to reverse the direction of your frictional force. Because the block now wants to move down the plane, then friction must be acting in the opposite direction to what it was before. So I've got a new diagram here with no P force on it and friction going the opposite way, and just like before I've resolved the weight into two components, a 6g cos 30 and a 6g sine 30. Now first thing I'm going to do is resolve my forces perpendicular to the plane, so n is equal to 6g cos 30. Now F max is equal to mu times n. We know that mu is 0.4, so F max is 0.4 times 6g cos 30, and if you put that in your calculator then this comes out to be 20.37 newtons. If I then look at the component of the force that's acting down the plane, this is 6g sine 30, and if you put that in your calculator this comes out to be 29.4 newtons. So this force acting down the plane is bigger than the frictional force acting up the plane, therefore the box is going to move down the plane. So we're going to conclude by saying that the weight component down the slope is bigger than the maximum friction, therefore box will move down the plane.